Lesson 7-7, Box and Whisker Plots. In this lesson, you'll learn to display and interpret data on box and whisker plots. Why is it important? Because box and whisker plots are a useful way to display data. They allow you to see important characteristics of the data at a glance. Let's take a look at this real-world application in Olympics. In 1996, the site of the Summer Games of the 26th Olympiad was Atlanta, Georgia. The table shows the number of gold medals won by the top 10 gold medal winning teams. Okay, we can describe this data using the mean, median, and mode. If you look at this carefully, we have Russia 44, USA 44 golds, total number of medals won is 101, all the way down to the Ukraine total number of 23. So we can also use the median along with quartiles and interquartile range. Remember, we studied the quartiles and interquartile range in chapter 6. So to be able to obtain the graphic representation of the data, a type of diagram or graph that shows quartiles and extreme values of data is called a box and whisker plot. Okay, suppose we wanted to make a box and whisker plot of the number of gold medals won by each of the nations in the table. First, arrange the data in numerical order. Next, compute the median and the quartiles. Also, identify the extreme values. Now, if you recall, when you talk about quartiles, it divides the data into 4 equal parts. Okay, 4 equal parts, meaning that in each quartile, there will be the same number of data. Okay, and we have your Q1, which is your lower quartile, Q3, which is your upper quartile, and Q2, which is your median. Just a little bit of a recall. And first things first, arrange them from least to greatest, and then find the median of your set of data. And if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. That means we have 2 middle numbers there. We have 13 and we have 15 as middle numbers. That means if you have an even set, you get these 2 numbers and then divide those 2 by 2. That is our median or our Q2. Okay, so the median, okay, for this set of data is the average of the 8 and 9 values. Okay, so if when we compute for the median, we're simply adding 13 plus 15, dividing it by 2. Okay, which will be equal to 14. Okay. Now, if we recall, the lower quartile Q1 is the median of the lower half of the distribution of values. Okay. The upper quartile Q3 is the median of the upper half of the data. Okay. So if you look at this one, remember too that if your median is not part of the set of data, that means you can use 15 all the way to 54 as your upper half, and 13 all the way to 7 as your lower half. So our upper half, okay, is 15 through 44, okay, and the median for the upper half is 20, and that is our Q3 or our upper quartile, and for our lower half from 13 to 7, and the median for our lower half will be our Q1 or our lower quartile, which is equal to 9. Okay. So the extreme values are the least value, LV, which is 7, and the greatest value, which is GV, which is 44. Those are our extreme values. Okay? And now that we have the information, we need to draw a box and whisker plot for this. Step number 1, to draw a box and whisker plot, draw a number line. Okay, assign a scale to the number line that includes the extreme values. Plot dots to represent the extreme values LV and GV, the upper and lower quartile points, Q3 and Q1, and the median. So we create a number line. Okay, not that one. Okay, this is our number line. And it says after creating the number line, plot the dots to represent the extreme values LV and GV. So our LV would be, in this case, 6. And our GV is 44 right there. Okay, so our greatest value is 44, least value is 6. And then we want to find our Q3 and Q1 and Q2. We already find our Q2, which is our median. So our Q3 would be right there, 19. And our Q1 would be 9. Okay, so that is the first step. Okay, step number 2, after creating our number line and plotting the points on top of the number line for LV, GV, Q1, Q2, and Q3, draw a box to designate the data falling between the upper and lower quartiles. So this is our number line, okay, and this is our box, okay, that represents Q1 and Q3, okay, and then another one right here, okay. So basically what it's saying is draw a vertical line through the point representing the median, okay. So this is the vertical line representing the median right there. Draw a segment from the lower quartile to the least value. So this is your lower quartile, and we draw a segment going there, okay. And one from the upper quartile to the greatest value. So that's our upper quartile. We draw one to the greatest value. And if you plot them, okay, this is our Q2, our median, okay, Q1, Q3, our greatest value, and our least value, okay. These segments are called whiskers of the plot, okay. These are your whiskers, the line that's drawn, okay. And obviously this is the box, and thus we have box and whisker plots, okay. So that's step number 2. So even though the whiskers are different in lengths, each whisker contains at least 1/4 of the data, while the box contains 1/2 of the data. Compound inequalities can be used to describe the data in each fourth. Assume that the replacement set for X is the set of data. Okay, so we have 1/4 of the data in this area, 1/4 here, 1/4 there, and another fourth in this part, okay, of our box and whisker plot. So the first fourth is X such as X less than 9. Okay, that's the first fourth of the data. X is less than 9. The second fourth is such that X is greater than 9, okay, right here, but less than 14, okay, which is our Q3. Our third fourth would be X such that X is greater than 14, right here, okay, and less than 20, which is this one. So this is our first fourth. Let me write down. This is our first fourth. This is our second fourth. This is our third fourth. And our fourth fourth would be X such that X greater than 20. So this is our fourth fourth. Okay, that's how we divide our set. Okay. Now step number 3. Before finishing the box and whisker plot, check for outliers. In lesson 5-7, you learned that an outlier is any element of the set of data that is at least 1.5 the interquartile ranges above the upper quartile or below the lower quartile. Recall that the interquartile range is the difference between the upper and lower quartiles, in this case 20 minus 9 or 11. Okay, so let's do a little bit of review. Okay, so when you talk about your IQR, we know that your IQR is equal to your Q3 minus Q1, the upper quartile, Q1. Okay, the upper quartile minus the lower quartile. And when you want to find your limits of your outlier, okay, so we're able to find your lower limit. The lower limit would be your Q3, which is your lower quartile, minus 1.5, your IQR. Okay, and to be able to find the upper limit, okay, you have your Q1 plus 1.5, your IQR. Okay, anything beyond those two limits are called your outliers. Okay, let me move them because it's going to cover my what I have. Move them up here. Okay, so we have our X to represent, okay, our upper limit is greater than or equal to Q3 plus 1.5 IQR. Okay, so X is greater than 20. Okay, since 20 is our Q3, 1.5 times 11 because our IQR is 11. So our upper limit is 20, x is greater than or equal to 20 plus 16.5 or 36.5. Anything beyond that will be considered an outlier. And you have on the lower limit, x is less than or equal to q1 minus 1.5 IQR. Okay, and our q1 is 9 minus 1.5 times 11 will give us x is less than or equal to negative 7.5. Any value below negative 7.5 will be considered an outlier. So finally, we'll do step number 4. If x is an outlier in this set of data, then the outliers can be described as x such that x, okay, is less than or equal to negative 7.5 or x greater than or equal to 36.5. Okay, so if you notice the word or, so you need to also remember the type of graph or will give you. In this case, there are no data less than negative 7.5. However, 44 is greater than 36.5. So it is an outlier. So the value 44 is an outlier. We now need to revise our box and whisker plot. Outliers are plotted as isolated points, and the right whisker is shortened to stop at 26. So if we create our box and whisker plot, okay, since 44 is an outlier, we simply leave it as a point, and we make our greatest value, okay, the second greatest value before the upper limit of our outlier. So 26 is the greatest value, okay, before 44, and that's where our whisker stops. Okay, and finally, let's refer back to the application at the beginning of the lesson, using box and whisker plot for the gold medals to answer each question. So after we have created our box and whisker plots, we can now answer these two questions. What percent of the teams won between 14 and 20 gold medals? Okay, so let's answer number 8. Okay, since the right half of the box in the plot indicates 25% of the values in the distribution, and since the box goes from 14 to 20, we know that 25% of the teams won between 14 and 20 gold medals. Remember, each quartile represents 25% of the data. Okay. Next question: What does the box and whisker plot tell us about the upper half data compared to the lower half? The upper half of the data is spread out. Okay. Why is it spread out? Because you have a bigger box and a bigger whisker, while the lower half is fairly clustered together. Okay. The secret word for this particular lesson, okay, would be Chihuahua. Again, hope you spell it correctly. Chihuahua will be the secret word for this lesson. Okay, and that's the end of our lesson. Thank you for watching.